Hi everyone, in this video we are going to discuss about DHCP snooping. So we discussed in previous video the theory part about this DHCP snooping, and in this video we are going to create a simple lab to demonstrate this idea of DHCP snooping. So let's start. So for creating this lab we need some clients, so maybe we can use these two computers as clients for our DHCP. And of course we need a DHCP server, and then we also need a switch, and on the switch we will actually activate or we will enable this DHCP snooping option. So we need this this switch, and then we need to configure this DHCP server. So first we need an IP address for this DHCP server itself. So for example, we are using this 192.168.10.1 as the IP address for this server machine itself. So first we are going to configure this IP address for this DHCP server. So 192.168.10.1 is the IP address for this server, and then we need to configure the DHCP services there. So this is ipconfig. Sorry, we need to go to services and then click on DHCP, and then we need to turn on the services, and then this is the pool name. This pool name is the IP addresses. We have IP addresses pool, and this is the name of that pool. So by default this is the name here, so we just use the same name. And then for this DHCP server, we want this server to advertise a default gateway information as well. So for example, we say 192.168.10.10 will be the default gateway information which this DHCP server has to send to the clients when they will be requesting for the IP address. So in addition to IP address, it also has to send the default gateway information, which is this default gateway. And then we have to give the start IP address within this pool of IP address, that is server pool. So we say our start address will be this one, 192.168.10.11, and then how many number of users we have in our lab. Let's say for example we have maybe 10 users there, and with this we just save everything, and now we have this DHCP server ready to assign IP addresses to the clients on the request. But we need to make connections in between those all nodes. Let's go to the connection and select this connection and say for example this PC to maybe 2, and then maybe we can select this one with 4.1, and we can select any random switch port for this one to connect this DHCP server. So we have connected this all the clients with the switch, and the switch has been connected with the DHCP server. And let's fast forward this one, and now let's go to this client, and from this client we have to make a request for an IP address using DHCP protocol. So we go to DHCP, enable it, it's requesting for IP address, and now it says that request is successful. And so in return to this request, this client has received an IP address, and you can see in addition to IP address, the subnet mask as well as the default gateway information has been sent by this DHCP server. In the same way, we can go to the next PC, which is our client, and we can go and we can select DHCP requesting for IP address, and we received an IP address from DHCP server. So this is an ideal situation where we configure DHCP server, and there are clients who are requesting for the IP server or IP address, and the DHCP server is assigning IP addresses to the clients. So this is good, and we want that. But actually, unfortunately, there are some bad guys in the organizations, there are some hackers who may do something wrong, something bad with the network. So for example, in this case, maybe a hacker comes, and that hacker comes with his own DHCP server, and in this DHCP server maybe he need an IP address. So let's say at the moment I'm working as that hacker, so 192.168.10.2, I'm going to assign this IP address to this DHCP server, and then in the services I'm going to configure these same IP address range, so that is same, and maybe again I'm say there are 10 users in the lab and I have to turn on the services. But for the default gateway, say for example now I use this IP address, maybe I have a second computer whose IP address this, and now this IP address I'm going to configure on this DHCP server, so that IP address will be used as the default gateway, and that default gateway IP address will be sent to the clients. So I'm going to close it and now make a connection from this DHCP server to some of the ports on this switch. So meet the connections, and we have connected. So as a hacker, so maybe we can give it a different color. So for example, this is some hacker there. Okay, so we have connected this DHCP server there, and now after this, it means in addition to the legal DHCP server, some illegal DHCP server is also acting there from the hacker. And now let's suppose that from this client, if we make a DHCP request for an IP address, see, if we make a request from there, and so you see that this service this is successful, and let's see, it's not getting the default gateway information. Let's see, we have configured the default gateway there. Sorry, we didn't give the default gateway information here, so that's 192.168.10.5. this is the default gateway advertised by this hacker. So this is the 11 and services on, and then we are going to save it. So maybe we made anyway. Now this is the DHCP server which we configured, and number of users sent. Okay, so it means only difference that this DHCP server which is by hacker, this will be announcing this default gateway. So let's suppose that we go again there and we try to get an IP address using DHCP. So you see, this time this user is getting this information. So now the default gateway is the default gateway information sent by the hacker DHCP server, and not from this one, from the legitimate DHCP server. So if you see, this is some challenging issue, that now all the traffic will go to the default gateway which is defined by this hacker DHCP server. Now this is the point to enable this DHCP snooping here. So what we do here, we can configure or we can enable this DHCP snooping feature on the switches, and for that actually let me for that we have these different ports, and we can actually classify these ports as trusted and untrusted port. And for that, what we are going to do, if you remember from the theory part, that we want to make all the ports as untrusted port, and then only that particular port who has connectivity with the legitimate DHCP server, that port will be configured as a trusted port, but the remaining will be configured as an untrusted port. So let's do that thing. So for that, we need to go to this switch, and in this switch we need to go to global configuration mode. So from privilege mode we go to global configuration mode using this configure terminal command, and from this global configuration mode we have this command, that is IP DHCP snooping. So by this we enable DHCP snooping, and then IP DHCP snooping and VLAN. So this is the VLAN where we want to enable this DHCP snooping. So for example, at the moment we have all the ports in this VLAN 1. So by default all the ports of the switch are already in VLAN 1. So it means on the VLAN 1 we are going to enable that DHCP snooping feature, and then we have all the ports on this switch should be untrusted port, should be configured as untrusted port. And if they all are untrusted port, it means they should not allow the the offer and acknowledgement message of DHCP messages. So we discussed about DORA messages. In those DORA messages, we had 4 messages. One was request, then offer, one was discover, request, offer, and acknowledge. Out of these 4 messages, offer and acknowledge message come from DHCP server, and we have, by this DHCP snooping, we have disabled those messages. It means now if any of the computer will request for an IP address using DHCP, they will not be successful. That request will not be successful. Let's see this requesting IP address. But because of that configuration, it says that this request has failed because all of the ports are categorized, they have been configured as untrusted port. We can try from this PC as well. Let's go there and enable DHCP here. So requesting IP address, and it says that it has been failed because all the ports are classified as untrusted. So we can also see, like we can see here, show IP DHCP snooping. So we can see here which ports are trusted port here, but you can see no interface is trusted at the moment. So it means no messages like belonging to this offer and acknowledged message are allowed through these ports. Now, to allow this legitimate DHCP server, we can make this particular ports where this DHCP server is connected, that is FA06, we can make that port as a trusted port. So for that, we need to go to that port or to that interface. So we go to global configuration mode, and then we say interface FA0/6, and then we say IP DHCP snooping, and then trust. It means now this port has been converted to a trusted port, and now this port should allow those the offer and acknowledgement message from the DHCP server. So now let's suppose that if you are going to try again, see requesting IP address, and it has received that IP address because now we have configured this port as a trusted port, and now DHCP server can send the offer and acknowledgement message from there. But rest of the ports will not allow this offer and acknowledgement message. So this DHCP server has been disabled by using this trick or this feature on the switch. And the same way, if we try on this PC, so we can use this PC, and let's say you can see it's receiving the IP address as well as the default gateway information, but this is the legitimate default gateway information. So you can try again, and you can try again as well. So all the times this will be receiving the same information. It means IP address and the default gateway, which is being transmitted by this legitimate DHCP server. So this was some idea about DHCP snooping, and we can see the binding. So in the one important point about this is DHCP snooping binding. So for that, we can see that show DHCP snooping, and then show IP DHCP snooping, and then binding, and we press enter. So this is the database, or this is the IP DHCP snooping binding table or the database. So DHCP snooping binding or database, binding table or database, this actually records the MAC addresses and the corresponding IP addresses which have been assigned by the DHCP server to the clients. So for example, in this case, if we go here, so it means this DHCP server on the request of this client, that is PC0, on the request of this client has leased an IP address that is 192.168.10.12, and the port to which this PC is connected is this one, that is fast Ethernet 0/2. So this is fast Ethernet 0/2, this one, and this PC has been assigned an IP address, and this is the MAC address of this PC. So let's maybe copy it, and if we're going to paste it here, so let's say this is the MAC address of this PC, which has been recorded in this IP DHCP snooping table here. And for this PC, for this second PC, this PC is connected with FA0/4. So you can see FA0/4 is the port number, and on that port DHCP server has assigned an IP address. So this is the IP address, and then this is the default subnet mask, or this is the physical address. Sorry, this is the physical address, and we can copy this physical address, and maybe we can paste that physical address there. And then I have just copy and pasted these physical addresses to verify there. So you can see here this says that this PC has an IP address of 192.168.10.12. So we want to verify this. So we can go here. I just can hover over there. You can see this is state that 192.168.10.12 IP address has been assigned to this PC. And we can go here and we can verify the physical address as well. So IP config and then all, and you see here we can verify that this is the IP address for this PC, and for the physical address you can see this is 00E0, so 00E0, and in the end this is AA0A, so AA0A. It means this is the MAC address of this PC. It means whatever information this IP DHCP snooping table has, so that information is correct. It means this is going to record everything correctly.